Hi everyone, here's our math problem for today. Given this figure, find the area of the blue shaded regions. Let's begin by looking at its basic components. We have a quarter circle here with a radius of 4 units. Then, we construct these two semicircles with a diameter equal to the radius of the quarter circle. So the radius of these two semicircles are both equal to 2 units. Then we shade this region and this other region, and we would like to find the combined area of these two blue shaded regions. You can pause the video and see if you can solve this elegant geometry problem. Now let's solve this problem. Let's start by labeling the parts. So we have two semicircles, and let their point of intersection be point D. This is point A, that's point B, and that's point C. Then, since the two semicircles are congruent and the radius are both 1/2 this 4, so you have here 2 units and you have 2 units here also, and you have here a 90-degree angle, we are effectively constructing a square. Then let's connect point B and point C, and we form this right triangle. Now the two sides of this right triangle are both 4 units, so we have here an isosceles right triangle, which means that the angle here is 45 degrees and the other base angle here is also 45 degrees. Now we have here a square, so this side AC must be parallel to this side ED. So this angle here must be equal to this angle because these are corresponding angles on the same side of a transversal that cut parallel lines ED and AC. So that must also be 45 degrees. Now it's 90 degrees here, this is 45, this must also be 45-degree angle here. Then let's connect point A and D. This is the diagonal of our blue square, and that bisected this corner angle, so it's 45 degrees here and another 45-degree angle here. That means that segment AD is perpendicular to segment BC at point D. You have here 45, you have 45 degrees here, and you have 90 degrees here. What we have is an isosceles right triangle BDA. That means side BD must be congruent to side AD. In the same manner, considering triangle ADC, this is 45 degrees here, it's 90 degrees here, this must be 45 degrees here. So this side must be congruent to side DC. And because of that, we now say that point D is equidistant to vertex B, vertex A, and vertex C of right triangle BAC. That means point D is the circumcenter of triangle ABC because the circumcenter lies at the midpoint of the hypotenuse side of a right angle triangle. Now, why is that important? That is important because going back now to our main problem, if you can show that these 3 line segments are equal and they are segments of the same semicircle, then this shaded region here must be identical to the shaded region here, and we can just transfer that shaded region. Also, since this segment is equal to that segment, and these are arcs of the same semicircle, I can now transfer this blue shaded region to this part, and we have just shown that the blue shaded regions that we are after in this problem is just the area of the quarter circle minus the area of this right triangle. So let's write that observation. We now say that the area of this blue shaded region, which is equivalent to the blue shaded region that we want to find, is equal to the difference between the area of the quarter circle minus the area of this right triangle. And if we can find the area of the quarter circle and we can find the area of this right triangle, then we have the answer to our problem. So let's do that. The area of the quarter circle is 1/4 the area of a circle, and the area of a triangle is 1/2 base times height. But what is the radius of the semicircle? The radius is 4 units. So this becomes 1/4 pi. R is now 4, and then square it. What is the base of this green triangle? It's 4 units. The height is also 4 units. So we have 1/2, 4 times 4. Then 4 squared is 16, divided by 4 is 4, times pi, you have 4 pi. 1/2 of 4 is 2 times 4 is 8. So 4 pi minus 8 square units is now the area of the blue shaded region that we would like to find. And therefore, this problem is now solved. So thank you very much. This is Lando Assistant, and we hope to see you again in our next video.